Having a look at something a little more tricky here, you might recognise this problem. It's from a previous video where we just used the formula triangle to solve it, because we established that it would just be the tan of the angle multiplied by the adjacent. But there is another method that's a bit more tricky, but it is important to know this because there will be some problems where you have to use this slightly more tricky method. What you're going to start with here is what the tan of the angle equals. And if you just cover up the tan here, you will see the tan of the angle is equal to the opposite divided by the adjacent. If we substitute in the values, the tan of 35, and that is equal to x, which is the opposite side we don't know, divided by 10. What we've got to do here is get the x on its own. There is a video about this in the algebra section, but just a very quick reminder that if you have something divided by 10, then if you use the inverse and multiply it back by 10, you've got rid of the division. So x divided by 10, if you multiply x by 10, you're getting rid of the divided by 10. Because you're multiplying this side by 10, you've got to do the same on the other side of the equation. So you will multiply the other side by 10 as well to balance it out. Now you have x on this side of the equal sign, and on the other side you have the tan of 35 multiplied by 10. And you might remember that's what you had to put into your calculator. The tan of 35, close the bracket, multiplied by 10, and that will give you the value of x. X equals 7.002, etc. You've been asked to round that to the nearest integer, so that will be 7 centimetres. Here's a similar one. Just remember that you're going to start with the tan of the angle is equal to, and remember essentially you're covering the tan in that triangle. Have a go at working out the rest of that. Press play when you're ready. The tan of theta, the tan of the angle, is equal to the opposite divided by the adjacent. So if we substitute in our values, the tan of 25 is equal to, the opposite is unknown, so that's x, divided by 3. We've got to get that x on its own. If you multiply the numerator by the denominator, you're using the inverse operation, so you're getting rid of the division. So x divided by 3, then multiply it back by 3. And you need to do that with the other side to keep it balanced. Now you have x on this side, and you have the tan of 25 multiplied by 3. Put that into your calculator. Tan 25, close the bracket, multiplied by 3, and that will give you 1.3989, etc., which you need to round to one decimal place, so that's 1.4, and that's in metres. If you're starting to feel confident, you might want to have a go at this one. You'll find that it's not tan, but you'll be doing the same thing that you've been doing here. If you're still not very sure, work with me through this one, and then have a go at the next one. Starting from the beginning here, you're going to label the triangle. So you've got the hypotenuse, opposite, and the adjacent is the side that's unknown. We need to find the length of that. Remember that chant, so, car, toa. Which of those do we not need? We're not using the opposite, so we can get rid of so, and we can get rid of toa. And we'll be using the cos key, the cosine. So the cos of theta, the cos of the angle, will be equal to the adjacent divided by the hypotenuse. So substitute in our values. The cos of 37 is equal to x divided by 16. And once again, if we multiply x by 16, we've cancelled out the division. So to get x on its own, we multiply it by 16, and then we multiply the other side by 16 to keep it even. So now we have, on this side we have x on its own, and on the other side we have the cos of 37 multiplied by 16. Put that into your calculator. Cos 37, close the bracket, multiplied by 16 equals 12.7781 and so on, and you're rounding to one decimal place, which is 12.8 millimetres. Have a go at this one. Pause the video, press play when you're ready. Remember to label the triangle first. Hypotenuse, opposite, adjacent. So, car, tower. Which of those do we need to use? Well, we're not using the opposite, so we can get rid of so and we can get rid of tower. Once again, we're using cosine. The cos of theta, the cos of the angle, is equal to adjacent divided by hypotenuse. Substitute in your values. The cos of 33 is equal to x divided by 19. Get x on its own. If we multiply that side by 19, we get x on its own. So we do the same with the other side. We now have x on its own on this side, and on the other side, the cos of 33 times by 19. Put that into your calculator to give you the side of the adjacent. And that should be 15.9347, etc. You're rounding to one decimal place, so that's 15.9 centimetres. Again, if you're feeling confident, you can go ahead and do this. If you're not quite sure, go through this one with me, and then you can try the next one on your own. Once again, label your triangle. Hypotenuse, opposite, adjacent. This time, we're not using the adjacent. So remember the chart? So, car, tower. Which of these ratios do we need to use? We're not using adjacent, so we can get rid of car and we can get rid of tower. This time, we're looking at the sin key, the sine of theta, the sine of the angle. And that is equal to opposite divided by hypotenuse. Substitute in the values. The sine of the angle, sin of 31, equals x, the opposite, divided by 9.5, the hypotenuse. Once again, we need to get that x on its own, so we multiply it by 9.5, and we do the same with the other side. We now have x on its own on this side, and on the other side we have the sin of 31 multiplied by 9.5. Put that into your calculator, you'll get 4.8928, etc., which you're rounding to one decimal place. So that's 4.9 centimetres. Have a go at this one. Press play when you're ready. Label your triangle, hypotenuse, opposite, adjacent. Again, we're not using the adjacent. So, car, tower. We're not using the adjacent, so we don't need car, we don't need tower. The sine of theta, the sine of the angle, is equal to opposite divided by the hypotenuse. Substitute in the values. The sine of 22 is equal to x divided by 111. We need to get that x on its own. We multiply it back by 111 to cancel out the division. And we do the same with the other side. Now we have x on its own, the other side is the sine of 22 multiplied by 111, which you'll put into your calculator, and you'll get 41.5813 and so on, rounded to one decimal place is 41.6, and that's millimetres. In the next video, you'll be dealing with fractions where the unknown value is the denominator, and you need to do something a bit different there.